Hello friends, let us discuss the important property of aggregates, that is the fineness modulus of coarse and fine aggregates. Now, the typical example how the fineness modulus of aggregates is solved is there on the board. Basically, the aggregates, whenever they are used in concrete, they should possess a particular size. The coarseness of the aggregates, the fineness of the aggregates means the size of the aggregates. If it is bigger, then we say that it is a coarser aggregate. If it is smaller, then we say that it is a finer aggregate. The coarse aggregates and fine aggregates, from the point of view of their size, we have already seen that they are classified just by the size as fine and coarse. So anything which is less than 4.75 mm, anything which is less than 4.75 mm is classified as fine aggregates, and anything above will be classified as a coarse aggregate. Now, in the concrete making, the best size for most of the grades of concrete is 10 mm, 20 mm, 30 mm, 40 mm. Higher size of the aggregates, coarse aggregates, will be preferred in high voluminous concreting like a mass concrete, or sometimes the concreting required for the dams. We have 80, 100, 120 to 150 mm. They are called boulders. The size of the average size of the coarse aggregates may be 80 mm, 100 mm, which is named as boulder. Generally, we are not recommending higher sizes of aggregate in normal concreting. A particular mixed design asks for a particular size of coarse aggregates, then that has to be followed, that has to be ordered to the crusher plant. The natural rock that is put to the crushers, and we have then different conveyor belts. They will be producing the different sizes of aggregates. So 40 mm, there may be some sieves, 40 mm, then 30 mm, then 20 mm, like that, and then we will get the aggregates of that particular size from the crusher plant. And whenever we order for that, we have to be very specific about the size of the coarse aggregates. Now, the size of the coarse aggregates is expressed as fineness modulus. Now, what do you mean by fineness modulus? This fineness modulus is just a number. It is just a number. So, it does not have any unit. Generally, that number indicates what is the coarseness or fineness of the aggregates. We have the standard set by Indian standards that roughly we should have 6 as the beginning line of coarse aggregates. Sometimes even 5.5 may be a coarser aggregate, but we should have 6, 6.8, 7, like that. We should have the fineness modulus of coarse aggregates like that. And in case of fine aggregates, we should have 2.4, 2.5, 2.6, like that, the fineness modulus of the fine aggregates. Now we can conduct a very simple experiment in the concrete technology laboratory. For that, we should have a sieve set. Now, what are the say Indian standard sieves? Indian standard sieve is a sieve of a particular diameter having the mesh attached to the base of it. The size of that mesh is designated as the IS sieve. We have IS sieve 80, 40, which are marked on this table here, 80, 40, 20, 10, like that. These are the grid size of that mesh. 80 mm, 40 mm, 20 mm, 10 mm. It is very simple to remember all these sizes. The second is the half of the first, third is half of the second, fourth is half of the third, like that. This is also 10 divided by 2 is 5, roughly 4.75 equal to 5. So 4.75, 2.36, 1.818, this is up to mm. Here onwards we have the micron sizes, and there can be a pan less than 150 micron is kept there. Now, if we have the coarse aggregates received on the site, and if we want to determine the fineness modulus of that coarse aggregates, we have to place all these sieves highest size in the uppermost position, 80, 40, then 20, 10, 4.75, like that. We have to keep all these sieves like this. These are held by a particular sieve shaking machine. There is a machine and which will be trying to revolve slowly, gradually in all directions, and thereby the sieves are shaken, and therefore all these sieves will be having a fall of aggregates from their aperture size, the grid size. So we can take a sample weight 15 kg. Again, Indian standards have given the standard weights to be taken for different sizes of the aggregates. If we have suppose 80 mm size, maximum aggregates we have received, suppose they are of boulder variety, then we should have 50 kg, 50, as the weight of sample. You can refer to that IS code and you will get all those standards. IS 2386, that is the code number. So all these sieves are arranged in the sequence. A standard weight 15 kg, actually it is mass, but we loosely use the term weight and mass. Here the first column is of course the sizes of the sieve. Second column of the table is the weight retained. So on the sieve shaking machine, we have to sieve all these aggregate sample for about 15-20 minutes, and then on the each sieve how much is weight retained, that we measure. So in the weighing balance, we measure the weight of those aggregates which are retained. The one which has been kept on the upper part of the sieve, the one which has gone through, that is not retained, that is weight passing. So this is weight retained. Of course, if you have suppose 10 mm, 20 mm as the maximum size of coarse aggregates received in the sample, all the particles will go down. Therefore, nothing is remaining. Similarly, on 40 mm sieve also you find that it is not anything remaining on that. 20 mm, even if we aggregates are say of 20 mm size, we order the crusher plant to have 20 mm size, there may be some oversized particles. They may be of 22 mm, 28 mm, 24 mm, like that. So some portion will be definitely retained, and weight of therefore those retained aggregates has come as 6. It is all in kilogram, 6 kilogram. Now 10 mm weight retained is 5 kilogram. 4.75 mm, it is the weight retained 4 kilogram. Now below 4.75, as we have defined aggregates which are lesser than 4.75, they are called fine aggregates. You will find, you should have rather, on 4.75 there may be something retained, but there should not be retained anything on 2.36 and lesser the sizes. One more check, all this put together, addition of these, you should have the total weight which you have already taken. So 15 kg. This is the second column. Now third column, we have to write cumulative weight retained on that sieves and in kilograms. So here it is 0, then 0 plus 0, 0, 0 plus 0 plus 6, 6, 0 plus 0 plus 6 plus 5, 11, 0 plus 0 plus 6 plus 5 plus 4, 15. And one thing definitely sure, that the last value should be the same as the total mass taken. This is the cumulative weight retained is entered in the third column. Now the fourth column shows the cumulative percentage retained. So if in 15 kg 0 is retained, in 100 kgs it will be 100. Like that, 0, then again 100, 40. 40 is the here we have the retained percentage. How that has come? 6 out of 15. Then how many out of 100? That is 40. So like that we have got all here, and from here onwards you will see that 2.36, then 1.18, all these values you will have 100, because here we are entering cumulative. Whatever is the value here, that percentage again we have to add, means 0 plus 0, 0, 0 plus 40, that is cumulative percentage of these 6, then 40, then 11 and 6, 17, then 17, you have to get the value of the percentage, therefore it will be 73.3. Here it is 15, here it is 100. So it is retained, cumulative percentage weight retained, and therefore all these if you add together you will get 713.3. Now what is fineness modulus? It is just a number. Number of what? Number, you can have a formula, the total sum of cumulative percentages of weight retained divided by 100. Means this fineness modulus will be, I'll write here somewhere, Fm is equal to cumulative percentages of retained weight and divide by 100. So I have calculated all this and I get 713.3, just divided by 100 you will get 7.13. Means the coarse aggregates which you have tested for the property of fineness modulus, the number is 7.13. The fineness modulus of these coarse aggregates is 7.13. Slightly higher, we can say, generally 6 to 6.5 is the acceptable and very good size of aggregates we can use. Doesn't matter if it is 7.13, we should not straight away decide that it should be rejected. So this is about the procedure. Now the same procedure is there for the fine aggregates. The sample taken, we have 500 gram, because sand we will not be requiring to take kilograms together, 5 or 10. We can have 500 gram. The same sieve set. Now how much will be retained on the weight of, say, the 80 mm sieve? The weight retained on the 80 mm sieve will not be there, 0. Every particle of sand will fall down. Here also, here, everywhere. Now there may be some size that if we have 4.75, out of 500 gram, there may be some 10 gram which are more than 4.75 mm size, and therefore they are retained. Then 50 grams are retained on the next sieve. Like that, these are actually readings from an experiment which has been done in the laboratory. This is a result taken. Actually one has to do that practical, get those actual weights, enter like this in the table, and then do the calculations, find out the percentages weight retained, cumulative percentages weight retained, cumulative percentages passing, and then apply this formula, the cumulative percentages of the weight retained divided by 100, and that you will get the fineness modulus. Now in this case the same thing is followed. We have 246 as the cumulative percentages of the weight retained. So 246, again we have to divide by 100 and we get 2.46. This is the fineness modulus of the fine aggregates. So Indian standard codes specify that the fineness modulus of aggregates which are fine should be 2.5, 2.4, 2.3, 2.9, up to 3, 3.4 also, sometimes even 4, but that may be coarser fine aggregates. That means the finer fine aggregates and the coarser fine aggregates. And we have seen in another article that the effects of aggregate properties on the concrete making. If the coarser aggregates are more, they may be helpful for workability, but there may be some problems of again filling up the gaps. So therefore IS code again has given the grading of aggregates, that also we have seen, and the grading curves are also available in the IS codes. We have to have all in aggregates. Single size aggregates in concrete technology is not allowed. That means it is only one size of aggregates, and then workability is a problem. Then the filling up the provision of the body to the concrete is again a problem. Hence we have to have a good amalgamation, a mix covering more number of sizes of the aggregates. But within that size, it should not be fine aggregates of more than 5 mm or 10 mm. Always in the range of that definition of the size. So here we have seen today what is meant by fineness modulus and what is the fineness modulus procedure to find out. Thank you.